Entitled Sea Surface Temperature Diagram Interpreter using OpenCV and ImageJig for Davao City rainfall correlation. I am Warren Kalim, a fourth year PSIT student from Ateneo de Davao University. Rationale and objectives. We will be doing an application using digital image processing to have research on the correlation of rainfall data of the Davao region to the sea surface temperature. And then
Restart.
This study
Sige.
estimates
This study will estimate the level of rainfall given the sea surface temperature of the seas derived from the digital image that we will be analyzing. The digital image that we'll be analyzing is from the site of the Naval Research Laboratory. From their side, they releases at most 4 images daily
of
of sea surface temperature diagram. We will be developing an application using digital image processing to automatically interpret sea surface temperature in such a way that it will be relevant to the banana growers of the Davao region, since there are several concerns of the banana growers to the rainfall. Then they can use our application for them to have a independent forecasting of rainfall given the sea surface temperature. Our specific objectives are to develop a utility that will automatically analyze the sea surface temperature diagram and interpret the diagram's RGB channel, which corresponds to a specific temperature in Celsius. We will be extracting the elements of the digital images, such as their features, the segments, and the hues and saturations and other RGB channels, or the red, green, and blue levels of the channels of each pixel. Then we will also calculate the average sea surface temperature of every ocean based on the based from the segmentation that we will be doing on the diagram using digital image processing. Then we will correlate the sea surface temperature and the rainfall data of the Davao region, and the correlation that we will be deriving will be used to forecast rainfall given the sea surface temperature. Methodology. This is your operational framework. The input will be the images from the Naval Research Laboratory, and in the middle box, this is the image processing portion of our study. There will be feature extraction, a model-based segmentation based on the ocean defined by the International Hydrographic Organization, and also the analysis of the RGB channels of each pixel. And then it will give us an output of numerical values and a weekly tally of the sea surface temperature. The numerical values that we'll be having will be used to correlate with the rainfall data of the Davao region. Digital image processing, the diagram analysis. So there will be, first, the diagram will be segmented and the feature will be extracted to know the portions of the diagram to be analyzed. And then the segmented portions will be the ocean based on the definition of the oceans of the International Hydrographic Organization, or IHO. IHO recognizes 5 major oceans, namely the Arctic Ocean, Indian Ocean, Atlantic Ocean, Pacific Ocean, and then the Southern Ocean. And then we'll also be doing a segmented portions of the Pacific Ocean, namely the north, the east, west, and south part of the Pacific, which will also be used for the correlation to the rainfall data. And then,
Kung man ng Southern Ocean yun.
Apo.
Okay.
And then including on the segmentation will be the marginal seas of each ocean. And then from the definition of the IHO of the boundaries of each ocean, its coordinates will be used for the segmentation. So given the coordinates of the ocean, there will be an analysis on the coordinates of the picture elements on the digital diagram, or the SSC diagram, and then the coordinates that will be and then the coordinates that we will have will be used to be translated into logical equation which will satisfy the area of the oceans. And
Gamit mo.
wait lang. And below, as you can see, these are the legend of Naval Research Laboratory of the temperature given its color. So each color has its own RGB channels, and the diagram that we will be analyzing will determine their temperature based on this legend, based on the identification of RGB channels whenever it satisfies the legend given by the NRL. So this is a sample of the segmented part of the oceans, of the 5 major oceans. So the segmentation is based from the definition of IHO, and then after the segmentation, it will analyze its temperature. Then the temperature that were identified will be used to calculate the average SST of each ocean, and it will be, and then the output will be shown in a console application such as the one below. It outputs the average temperature of each ocean in degrees Celsius, and this data are being shown on a comma separated file or a CSV file. CSV files are files which can be used on Microsoft Excel or other spreadsheet softwares. The data processing. For the data processing of our application, it will allow us to have an image archiving, to tally the weekly sea surface temperature, and then there will be also graphs which will be producing. First is the bar graph, which illustrates the level of rainfall that we forecasted, and then the line graph, which will be a linear representation of the SST by year and ocean. The rainfall forecasting, which is shown on the bar graph, is being computed and derived from the results of correlation and linear regression of the rainfall data of the Davao region and the sea surface temperature of the oceans. So this is a sample of the line graph that we'll be producing. This is a line graph of the year 2010, and then you on our application you can generate sea surface temperature. You can generate line graphs of the SST given that data are available, and then based on you can produce line graphs based on the ocean and the year of the data given that the data are available. Main results and discussion. Since there is already a statistical tool available, then we'll be using that for the statistical portion of our project. The correlation is done on the PWS Statistics 18, and then the process we will be using is the Pearson Product Moment Correlation Coefficient, or Pearson R. This is to get the relation of a given SST to the recorded rainfall level in the Davao region. The group has 4 correlations for the recorded data gathering, which is this 4, which you can see on the projector.
And the projected image.
On the projected image. So it means that the week 1 of for the first, the week 1 of rainfall and week 1 of SST means that this week's sea surface temperature to be correlated to this week's rainfall data, and then from the computation that we did, the output gives us that the Pacific has a very low correlation compared to the other oceans, which only have low correlation. So for the next step, we'll be using the segmented part of the Pacific rather than using the data that can be extracted from the whole Pacific. First is to avoid redundancy on the data, given that we have the data from the whole Pacific and the data from the segmented parts of the Pacific. Second is that from the first correlation that we did, we got a very low correlation of the Pacific to the rainfall compared to the segmented part of the Pacific, which only gives us a low correlation.
Which is a result of low.
Which is
a better result of low
Nakalimutan
correlation.
kong sabihin na ang correlation kinagyan siya for a year.
for this.
For
Kaya
the
pwede
correlation,
baliktarin din yun yung week 1 SST, week 1 rainfall, week 1 SST, week 2 rainfall, week 1 SST. Dito tanan si week 1 SST.
so the correlation will run for 1 year, since the rainfall data that we gathered is only available for the year of 2010, and then the sea surface temperature diagram released by NRL only allows us to have their images from the year 2000 and 2010. Since our rainfall data only lasts for 1 year, then our correlation will only run for also 1 year. Linear regression. This process will be done to determine the predictors and the coefficients for the prediction. So it will determine us which of the independent variables can be used to derive the dependent variable, which is the rainfall. So from the calculation that we did, these are the output. So as you can see, the last correlation that we had has the highest Pearson R and the least standard error of the estimate. So for the forecasting of the rainfall, we will be using the coefficients of the fourth correlation, and below and on the below table you can see the coefficients which will be used for the computation of the forecasted rainfall given the SST data. Conclusion and recommendations. The group successfully segmented the diagram into the 5 major oceans and determined the marginal boundary seas, and able to generate relevant information to the banana growers that is related to the forecasted rainfall level for a user-selected period. Recommendations. It can be extended and be made to be more environmentally beneficial. Aside from the sea surface temperature, the sea salinity level will also be automatically derived, interpreted, and studied. Salinity level is just an example for the extension of our project. This is for us to get the vapor produced of every ocean given the sea surface temperature using the Closure-Clapeyron equation. Using that equation, then we can get the produced latent of vaporization of each ocean. And then the extracted output can be used to calculate the vapor amount. And also, our extracted numerical values can be used to study other